Hello students, now in class 11th, today I start a new chapter, which is the last chapter of this 11th class, that is the wave motion. Wave motion. First is the question that what is the wave and how does it travel and what are the characteristics of the medium and how many kinds of waves are there. So this is will be discussed in this chapter. First I am taking the wave. The chain of disturbance produced in medium is called wave. The particles of medium execute SHM during wave motion. The medium does not move in propagation of wave. There is the waves transport energy and momentum, but not matter. The waves are produced only when there are the vibrations or there is SHM of the particles in the medium. So as the disturbance is produced, the particles start to vibrate, and as a result there is a chain of this disturbance. The particle continue to move. So they constitute the wave. When the wave propagates in the medium, the wave transports the energy and the momentum, but the medium itself or the matter is not transported by it. And you can see that this is not only the method of transport of energy. There are some other methods also, like the firing of the bullet from the gun. When the bullet is fired from the gun, then there is transport of energy, momentum, and the matter also, because bullet itself goes towards the target. So this transport of all the three things: energy, momentum, and the matter. The firing of bullets by gun transports energy, momentum, and matter. because bullet itself moves in medium. So medium is not transported, but only the transport of matter, that is the bullet. So this is what the difference of these. This is also the means of transfer of energy. This is also a means of transfer of energy. Similarly, if you throw the stone, then you are transporting the energy and momentum. But the stone is itself going towards the target. So this transport of matter also. But in which you are transporting, in which you are throwing to this stone, then medium itself does not move, but the stone itself move from one point to another point. The medium should have following properties. For propagation of wave. These are number one, inertia, and number two, elasticity, and number three, low damping. Low damping. Inertia and elasticity are necessary for the SHM of the particle of the medium, and damping is low because if the damping is very high, then the wave cannot propagate in the medium. So damping should be less as possible. Types of waves. They can be classified in two ways. Number one, on the basis of vibration, and second, on the basis of medium. So now I will take both of them one by one. First I am taking the types of waves on the basis of vibration. Basis of vibration. Now the waves are of two types. Number one, longitudinal wave. Longitudinal wave. When the particles of medium vibrate in the direction of wave propagation. Such wave is called longitudinal wave. Now in longitudinal waves, there are compressions and rarefactions. Alternatively in the medium. It means that the longitudinal wave moves in the medium because of the compressions and the rarefactions. The compressions have high higher pressure and density than normal pressure and density of medium. While rarefactions have lower pressure and density than normal pressure and density of the medium. So compressions means where the particles are very close to each other or the layers of the medium are very close to each other. Then definitely their pressure is high and density is also high because the layers are very close to each other, so volume is less, the density increases. And rarefactions, the layers of the medium are away from each other, so they have low pressure and low density than the normal one. So thus rarefactions and compressions takes place in a medium. The longitudinal waves cannot be polarized. Polarized means that the vibrations cannot be held in one direction. So now you can see that this is suppose then again the rarefaction, then again the compression, so what we have that this is the compression. And this is rarefaction. You can see that they are alternatively exist. If suppose first is the compression, then the rarefaction, then compression, then rarefaction, and then compression, so they continue. Now we can represent to these in the form of wave. This is now suppose this much, and this we take the this y and the wave propagate in the direction of x. So you can have so this corresponds to this one, this corresponds to this one, this corresponds to this one, and this corresponds to this one. So this is this is this is the compression, and this shows the rarefaction. So they are alternatively. All. This is the graphical representation of longitudinal wave. Graphical representation of longitudinal wave. Longitudinal. Now you can see that here the particle and here this, all the particles at the compressors are in the same phase, and also the particles in the rarefactions are also in the same phase. All compressions are in same phase. Same phase or phase difference of 2 pi radian. Similarly, all rarefactions are in same phase or phase difference are in same phase or having phase difference of 2 pi radii. But you can see that the compression and rarefaction, they are in opposite phase. Compression and rarefaction are in opposite phase. And have phase difference of pi radii. Thus, compressions have the phase difference of 2 pi, the 2 pi, 4 pi, 6 pi, 8 pi. This is the even multiple of pi. Then it is called in the same phase. And in opposite phase means the phase difference is pi, 3 pi, 5 pi. So odd multiple of pi. Then this is the in opposite phase. So this is about the longitudinal wave. And now I take the second one, that is the transverse wave. Transverse wave. When particles of medium vibrate perpendicular to the wave propagation, it is called transverse wave. Transverse wave. There are crests and troughs. Alternatively, in the medium. Crests and the troughs are that I can show it here. the transverse waves can be polarized. So now how to this? So we have the graphical representation of these waves is of this kind. This is your x 0, and here we take the y, and then we are having this is x. So now you can have that these two make the crest, and this are the troughs. So crests are the point of positive amplitude or the positive displacement, and troughs are the points of negative displacement. In crests, the particle have positive displacement, and in troughs the particles have negative displacement. Representation of the longitudinal wave and the transverse wave is the same. Graphical representation, there is no difference, but there is only the meaning that in case of the longitudinal wave we are having the rarefaction compressions, while in case of transverse wave we are there are the crests and the troughs in the medium. Alternatively, all the crests are in the same phase and all the troughs are also in the same phase, and they have a phase difference of 2 pi radian. All crests are in same phase or have phase difference of 2 pi radian. All troughs are in same phase or have phase difference of 2 pi radian. The crest and trough are in opposite phase. And have phase difference of pi radii. So as I told you that this 2 pi, 4 pi, 6 pi, the even multiple of pi, they are having the same phase, and this pi, 3 pi, 5 pi, 7 pi, the odd multiple of the pi, then they are in the opposite phase. So the difference between the transverse and the longitudinal waves is that there are the troughs. There are, in case of longitudinal wave, we have the rarefaction compression, and it cannot be polarized. In case of transverse wave, there are the crests and troughs, and these waves can be polarized. So now I take the example of these two. Example of longitudinal wave. And this is your sound wave. Sound waves in gaseous medium. In gaseous medium, sound waves are always longitudinal, but as they can also be produced in the strings also. They can be produced in stressed strings. So how in stressed strings? Just suppose we are having a thread, and just you tie up its one end at the rigid support and other you held in your hand, and then just you stretch it and leave. The thread will move in the direction of the length of the thread. So this there is the longitudinal wave in the thread. If suppose the thread is swing perpendicular to the length of the thread, so then there will be the transverse wave, because the wave will travel along the length of the thread, but vibrations in the thread are perpendicular to the thread, to the length of the thread. And now examples of transverse waves. That is the electromagnetic waves, So all kinds of electromagnetic waves like gamma ray, cosmic rays, ultraviolet rays, or the lights, infrared, red, and the radio waves, TV waves, they all are the transverse waves, and they are the electromagnetic waves. And they can be produced in stressed string by swinging it perpendicular to its length. Also, the transverse waves can be produced, the transverse and longitudinal waves both can be produced simultaneously in the same medium. So this is what that I have told you on the basis of vibration. And now if we take on the basis of medium, basis of medium. This I have told so far now on the basis of the vibration. Now I am taking on the basis of medium. So the waves are of two kinds. The waves are of two types. Number one, progressive waves. Progressive waves, or better to say it, the mechanical or elastic waves, and second, waves in vacuum. Now these, first we take the elastic waves. Mechanical or elastic waves. The waves produced in material medium, material or elastic medium, they are called mechanical or elastic waves. So these waves are further of two kinds. These waves are of two types. Number one, the progressive wave. Progressive wave. The progressive wave, it transports energy and momentum, but not matter. The progressive waves may be the longitudinal and transverse. These waves are of longitudinal and transverse. Both. They can be produced, and you can see that the examples of these one sound waves, in material medium, both the waves can be produced simultaneously. During earthquake. The waves inside the earth are longitudinal, but on the surface of earth they are transverse waves. Similar happens when there is blast of a bomb in the water of a sea. So inside the water there are the longitudinal waves, and when the waves are on the surface of the water, then they will be transverse. So they produce both. And now this is the progressive waves also represented by graphical way, as I have told you. There is no difference at all. So this is the, and second wave is in this one, that is the stationary Now one more point. These waves are produced in boundary less medium. And now I am taking the second, stationary waves. Stationary or standing waves. So stationary waves, the waves produced in a bound medium are stationary waves. Like waves in stressed string or waves in organ pipes. These waves do not transport energy. There is no transport of energy in these stationary waves, so they have a constant energy. And this what happens that in the medium at some point if the energy is lost, then it will appear on the next point. Then in the further next point this will disappear, and then on the next it will appear. So the energy in the medium remains constant. Energy in medium remains constant. So at the same point, and as such the stationary waves are produced due to the superposition of the waves. These waves are due to superposition of waves in the medium. So this is what the stationary or the standing waves. This is what I have told you about the stationary waves. And stationary waves are also both kind, longitudinal and transverse. The stationary waves are also longitudinal and transverse. So this is what we have taken on the basis of the elastic medium, and for this I have told you that they produce in the elastic medium. The medium which I told you earlier that the medium should have the properties of elasticity and the inertia. Only then these waves can be produced in the medium. And now second was the waves in vacuum. It was the way of on the basis of that waves in vacuum. Now these waves are always transverse waves. They are electromagnetic waves. The speed of EM waves equal to 3 into 10 raised to the power 8 meter per second. That's the speed of light. Speed of light. So waves in the vacuum are always transverse in nature and they can be polarized. They can be polarized. So polarization will take place only for the transverse waves and there is no polarization for the longitudinal waves. So this is what I told you, that what is the wave and which kind of waves are there, how can we divide them, and what must be the properties and how they travel in the medium. So you all like, share and subscribe this video, and you can also see that the velocities of the longitudinal and transverse wave may be the same or may not be the same. So they have the different velocities. So that I will discuss later when I will tell you the velocity of the sound waves. So you all like, share and subscribe this video. Thank you.